Hi, let's see a little bit about how you can create network visualizations, especially for simulations and node-link representations using D3. Here is an example network that includes all of the possible handles that I have used on my Twitter, like over the history. So I downloaded all of my 5,000 tweets. And then what I did is to build this network based on that data. So in here, I have started a new notebook, and I just uploaded the 7 megabyte file that contains all of my tweets. And to get started, I guess we can just come and say import D3. So, and then load the tweets. I guess we can do that just using Observable, using a file attachment that goes and says, here are my tweets, and converts that into a JSON file. So now we have the 5,000 tweets, and as usual, I like seeing them, so I'm going to use an Avio. And this is just going to be for us to have an extra way of filtering, and then also for summarizing the tweets. So let's say that we are going to create here selected tweets, or I guess tweets, and then out of that show an Avio of my tweets. So the first thing we need to do is that we actually need to compute a network out of this. So when you think about that and you start looking at the data, you will see that each tweet, I found that it has this nested attribute called entities. And then inside that, whenever we have hashtags, then I use this one in here, so we can build on that. So to build the network, I'm going to be using like the code that I wrote in here for doing that. The reason why I'm not going to write it from scratch is that it takes a while to build that, and I don't want to make the video too long. So let's go and do this in here. So basically this one, let's comment this out for the moment, and then this is going to be selected tweets. Selected tweets. And then I also need this other function that it's called find or add. So let's put that in here. And finally, the get tweets, the get key, this one in here. So I still can explain to you what this one does. I think it's working now. Okay, perfect. So the way I did this is that I just iterated over all the tweets in here. And then I started doing a nested for loop over the hashtags for each one of the tweets. I did it twice because I wanted to create concurrencies. And notice that this one starts from whatever position this one is, so we don't have duplicates in there. Then the thing I do is that I call this function getKey using the text of each one of the handles. And what getKey does is that it compares the two texts, and then it looks which one is smaller, and then it returns either A tilde B or B tilde A, depending on which one is smaller. You want to do that because basically you want to count how many times it's in there, for instance, database and Colombia. But if you create a key that it's database Colombia and then create another one that it's Colombia database, that is going to be a different one. So basically what that gives you is regardless in what order you pass them, always the same key. So I do that. Then using a map, if I don't have the key, I start initialize that with 0 because I can count how many times it is in there. And then I just add up 1 to that. Once I have that D keys or D links, I create another map for the nodes and a list of the links. And then what I do is that I iterate over the links. I also want to count how many nodes are in there. So like how many times a node has a link. So basically I'm creating another map for that, finding a node, like checking if the node is in there. If not, then initializing it with an ID and a value of 0. And then if not, returning it. And same thing, I'm just adding 1 to the value of that, and then pushing into the list of links like a source and a target, because this is the format that you need for visualizing networks in D3. You need an array of nodes, and then you need an array of links that has source and target references. And in that case, it can be either the whole object, or the reference can be including only the ID. So that's what we are actually using in there. Finally, I create a network object that is this one that you're seeing in here, and that's the one that we are returning. Later, we're going to be using a clustering library that I have, that is this one. So that's why I'm commenting that one out. So this is the very first starting point, I guess, or the very initial point. And then you can see all of the nodes that I have with how many times I have used it with another hashtag. And then in here, you have all of the source and target. And right now it has like the whole link to each one of the nodes. So the way you visualize that with node link representation, it's using a for simulation. So the way the for simulation works is that you can create an instance of this. And then this is going to be an instance of for simulation in here. And then that one will take as a parameter in here the nodes, okay? So usually you will find examples that Mike Bostock does using creating first this line. It takes the network and then extracts the nodes out of that, and then it just make a shallow copy of them such that we can make sure that we are not modifying the original data. And that can be especially important when you're working in Observable, because this cell is going to be rerunning many times. So unless you do this, then what's going to happen is that you're going to get garbage from the previous one. So I like doing that at the beginning, but then disabling that so I can have actually animations when I change an input or something. The other thing you want to do is that it is very important to do this on Observable. And this is something that only happens in Observable, and is that you should put a rule that takes the cell, and if the cell is dirty, which means it needs to be rerun, then you want to stop the simulation, because different to every other function in D3, when you launch a for simulation, it will start running on its own, and it's going to be running on the background, and you need to tell it to stop, otherwise it's going to spin out another simulation, and then you're going to get garbage from the previous one, and it's going to be very unperformant. So once you have done this, like the for simulation takes as parameter the nodes, and then the interesting thing about this is that it will take those nodes, and if we, for instance, return here the nodes, you're going to see that what it is going to do is put an X and Y value on the nodes. So if you want to visualize the nodes, in this case, then basically what you do is that, like the typical thing, you just create an SVG, or you can do that in Canvas. Actually, it's better to do it in Canvas because many times you want to put too many nodes or links, and it can become very unperformant. So in this case, I want to use the typical trick of the width and the height for the view box. So it will expand in there, and then I guess I can put the height in here. Let's say that the height is going to be 400 pixels for the moment. And finally, you want to return your node in here. So when you're drawing your nodes, the way that you usually will do it on D3 is that you will say, take your SVG, because we are not using any margins. Then you select all of the nodes. In this case, let's be lazy and just put the circles, and then do data binding with the nodes. And then first make sure the circle is created or joined, and then do an attribute CX, and the D being D of X. Notice that I'm not using a scale for that, because like the whole for simulation is already using this standard, okay? And then I will need a radius in here, and then I will have a bunch of points in the top, as you can see in there. So this will be the X, and this will be the Y, and then we get this element. So that's a good starting point. However, one of the keys of the for simulation is that you want it to be updating every time the simulation iterates. So let's put this selection on a circles variable. And then what I'm going to do is that I'm going to move this down here. And then this for simulation, it's going to have a parameter called tick. And then that is going to be a function that you're going to be calling every time the simulation updates. So what I'm going to do is that I'm going to create my ticked function in here, and then put inside that what I want to do. So actually what I want to do in here is that I initialize these things. I just wanted to keep the R where it is, and then like start with the radius, and then inside the tick function, I'm going to be updating this thing. So what I'm doing in there is that every time the simulation runs, then it's going to be calling this, and therefore it's going to be updating the simulation. Now with this, we can start adding forces, because the force simulation, the way it works is that you put certain forces that change the way the simulation works, or the visualization works. So for instance, the most important one, maybe it's having, or actually start with a charge function. So let's say we do this one, and then there is a force for that called force many body. And if you do that, then basically all of the nodes, as you can see on the top, are going to try to repel each other. And then there, as you see, they try to expand on the screen. So having done that, like you want to have another force that actually sends them to the center. If you have a network that it's not, it's a connected network like the one we have, then you can use force center. If not, you can use force CX and force X and force Y to try to send things to the middle. So basically, this one is going to try to send things to the middle, and the other one is going to try to separate them. So for instance, if I remove these ones, you can see that now we have another force that separates things. So those two are at play, and then you can also change the strengths for them. So for instance, you can say, I'm hoping strength, I'm guessing it's like this. And then you pass a parameter that is between 0 and 1, like the default value is the default value is 0.1, so that way you can make the force stronger. Again, since this is an unconnected network, then it's expanding too much. So if you want to keep the nodes in the center, then you can use force X or Y. Okay, like for instance, let's do that one like at least on X. So let's comment this one out, and then let's say that we want to force X, and then we want to send everything to at least half the width. And then as you can see, now they have started collapsing. So again, if you have unconnected networks, use force X and force Y. Now, to complete this, the final one that you need, it's a force link. And then excuse me, this is the force that is going to be joining the nodes by the links. So when you start doing this one, the whole idea of this one is to try to keep the nodes together that have a similar value. And then you also want to draw them. Actually, I'm seeing this might have a mistake because I'm not seeing that it's actually putting them together. I wonder what I have in my links in here. So it seems that my links here are okay, and but it's not finding them. I wonder if I should put an ID that says that I'm identifying my nodes by the ID. No, that's not it. So there might be something else. I wonder what it is. It's not that one. It's like this one is not doing anything. I wonder if maybe my links are broken. So let's return them in here. And so yeah, I do have a link in there. It's starting with a broken value. I think I know what's happening. So one of the problems of this is like, yes, so this is going to be tricky. So basically you want, since I'm creating the copy of the nodes in here, basically when I created the copy, then the links that I had before aren't really linking to the original nodes. So that's a tricky one. So what I'm going to do in here is that I'm going to say, let's call this L, so it's more differentiable. and then say that this is going to be, the source is going to be the source.id, and then the target is going to be the l.target.id. So by doing that, then now they should be connected, and then I can use this to say, hey, you should identify your nodes. Like the way I'm going from my links to my nodes is through the ID. So what I'm passing in here, like this source, this is what you have to search on the nodes with ID. So let's get rid of this return. We don't need it anymore. And now that's what I wanted to see. So that's a tough bug to fix in here. So now I have a force many bodies, so they're separating. Then I'm sending them to the center. And since all of these are hashtags, then maybe it will be better just to actually show the text instead of showing the circles. So let's say that you want to show the text. You do that in here, same thing here, and then you want to change the color for them. Let's say they use 333, so it's like a grayscale, and then the text, excuse me, and the text will be t.id. Okay, so now that I have done that, then I can replicate the same thing I did in here, but with the text, because the text is in there. It's just that it's not really moving with the animation or the iteration of the simulation. So now I can put it like this. So now this one should be moving the text in there. So let's change a little bit the style. So we can have a style in here. Excuse me again. That it's an HTML style, and I'm going to say that all of the SVG text is going to have a font family of sans serif. And then let's say that I also want them to have a font size of 8 points. Although I'm going to change that in a minute. So now that seems to be a little bit too big. Am I missing something in there? Yes, like this S shouldn't be here. So now it's a little bit smaller, and as you can see, well, actually the text, the circles aren't really doing much for us in there. So let's get rid of them. I think it looks better like this. It's a little bit more readable at least. And then let's put another style that says that they all should have a text anchor that is in the middle, like this. And then this is looking better. So now I have this, I don't want the text to be selectable like this. So let's say that the cursor is going to be pointer here. So at least it will look like a hand. That's better. And then I also want to show the links, of course. So what I'm going to do for those, it's pretty much the same thing I did with the nodes. So I'm going to copy this, I'm going to put them in here. I might want to put the nodes or the links behind the circle, so let's put them in here. Later when I update them, it's important that you update them first so they actually go underneath. And then this is going to be my lines. And this is going to be a circle line, and then circle, not circle, but line. And then this one also should have a style that is going to be stroke with, let's say, again, CCC. I don't want to put that too dark. So, and then very important, you need to move them in here. So you have to make sure that they update in here. Because remember, this is the function that runs that runs every cycle of the simulation, so that way you can make sure that they are updating in the animation. So basically you want one for, and this is going to be links, and then the links come in the source and target. And once you run them through, remember that we had to transform that into IDs, and then once you run them through the for simulation, they actually get links. They get references to original objects, so you can actually access the X and Y attribute as I'm doing in there. And then we can duplicate this, that looks better. And then we can change x1, x2, and then this is going to be my target x and my target y. So basically what I'm saying in there is that I want to align from the source xy to the target xy. And of course it doesn't work. Let's see if this is throwing an error. You cannot get property x of undefined. Source. Oh yes. So one of the problems when I was preparing this, I did exactly the same error. So I was passing the data, I was passing the nodes, but actually I want to pass the links for this. And did that help at all? It seems like it didn't. Let's see this one again. And you can see that this is running many times. So the reason why it's doing that is because it's running once per each simulation. So that's why we're seeing that. This is called lines. Oops, I really screwed up here. So this one is the one that should be links. And that's much better. As you can see, one of the problems is that it's kind of very dark right now. Like you could change, for instance, the opacity of your links to have something like CCC. And with some transparency, sometimes it helps. But remember that we have a value for the links and another value for the nodes. Then we can show that in there as well. But before doing that, like there's also another problem, and is that you have a lot of nodes that are getting out of the screen. So since I have faced that problem many times, I actually created a library for that it's called D3 force boundary. And you can import that with as an npm module. So if you search for it, D3 force boundary, you will find it in npm and also in Observable, as you can see in here. And then what this thing does is that it keeps things inside whatever square you say to it, or establish to it. So basically you have to pass 4 parameters, x0, y0, x1, and y1. Oops, I have an error in here. This should be y1, sorry. So coming back in here, the way we import this is not import because it's not a notebook. Then you say force boundary equals require D3 force boundary, I think is what it's called. Of course, that work. And then I can add that to my simulation. So I can put that in here. And then I just say I'm going to have an extra force. That it's a boundary. Whatever you put in here, it doesn't matter. So you can just put whatever text. And then here comes my force. You can even create your own forces. So if you search the documentation, you will see it's not that difficult. And then you say this is going to go from 0 to the width height. Let's actually say that it goes from 3, just because on the top I want to have space for seeing things. So now things are trying to stay together, but as I was saying before, I want to see the value of the links and the nodes, okay? So I want to see what are the most important words. So for that, we can create a couple scales. So let's create a scale called opacity, and it's going to be a scale linear. And this scale is going to have a domain that goes from the D3 extent of, this is going to be for the links. So this is going to be network dot links, and then I just need the dot value, and the range this is going to go from, it's like opacity goes from 0 to 1, so I can put it like this. And then what I do with that is that I can take my links in here, and then instead of passing the opacity in here, that is by the way that fourth attribute, you can just say opacity is going to be link passed by the opacity scale dot value. That is where I'm actually going to get the value of the links. And then seems like that didn't work that well. I wonder what could be going wrong. So let's see if this one has a good domain. So the domain seems right. And then let's try, did I spell it correctly? It seems like I did. Maybe it's stroke opacity. that one doesn't seem to work either. So let's make this a little bit smaller just for the sake of it. And then let's inspect just to see if it is actually passing the attribute. So I'm getting an error in here. That should be an old one. So I have here my lines and I see the style, but I don't see the stroke opacity. So what can be the error in there? Let's put it like this just to see if it changes anything. I don't see it's doing anything. Let's try it like this. Will that work? So that did work. And then let's go back with this one. So let's see, for instance, that I take the opacity of my network dot links and then the first one of those and the value. That is what I'm applying. So, and if you see the first link, it's 1. Let's see that I go from 0.1 or something. So that's working well. Let's say with 6. So that one is 0.7, so that should be working as well. Oh, and that's on my lines. What can be the error? Stroke opacity. There's something wrong in here. Changing the style. I wonder if changing it as an attribute will change anything. So there's something that's not working for me here. So let's do a console log at least in here so I can see what is the L, and then I want to see this one as well. And then return opacity of L dot value. And let's see that in the console. So I have a bunch of those, so that's more encouraging. So now this is saying that the opacity for this, it's undefined, and then there we go. So here is my problem. So I was mirroring the object, but I wasn't mirroring the value, so or copying the value. So now with that, now I have some opacities in there, and it's exactly what I wanted to see. Good. So now I have those elements, and we can see them moving. I want to see the same thing with, and then maybe I think this is a little bit slower. Yeah, I think it with the stroke opacity, it works a little bit faster. Yes, that's what I wanted to see. So now you can see that, for instance, the connection between D3.js and database is one of the strongest ones in the data. So we can repeat the same thing with the value for the size. And then this one is going to be scale linear, but in this case is going to be with the nodes. And then the scale, let's say that we want to go from 4 pixels to 18 points, okay? So having done that, we might want to change the style. Remember that we had said that this is going to be my font size. So let's leave that to be defined one by one. Let's make this like this so it's a little bit easier to read. And then they should be really big now. And then on the text in here, we do the same thing. So we say font size, probably do that with style. And then node.size.d.value. Okay, and I need to add probably the point in there, and that's what I wanted to see. So now it's a little bit more readable. Then you can, like for instance, if you want to add drag into that, which is a very nice feature that you find in Mike Bostock's examples. Let's try to see if we can find one of those really quickly. I wonder if from Google we can get there. Not the first boundary. I was using my previous search, and of course my network gets slow during the recordings. So since it's taking so long, I'm going to do it from here. So basically what you need to do is that, on my other example, is that you need to create a drag function. And what that drag function does is that it looks at the event, it finds the node, and then it sets the fx and fy. And those are attributes that is kind of like the node is going to be fixed while I'm dragging it. And then when I drop the dragging, it's clearing up these things. So if you want a node to be pinned on the screen, then you can just pass the fx and fy, and then it will stay in there. So after doing that, the only thing you need to do is that whatever is going to be your node, you just do the typical call, and then I think you say in here drag and then simulation. And so because of that, I will need the simulation. As you can see, Observable is complaining that it's not in there, so I'm actually going to do it this way. So that way it's already been defined here like this. And then hopefully with that, now you can drag nodes, as you can see here. There's a ton of other parameters that you can change on this, like for instance, if you don't want the nodes to distribute that much, you can also change, for instance, what is the strength of each one of these things. Remember, this is going to be a negative value. So you put a lower value, then maybe nodes don't go that far away. The other thing, remember the clustering library. I also have a library for that, so I think it's called net clustering. And in here is just, I think, net clustering, I think is what it's called. There we go. And then that has a function that it's called cluster. That is this one in here. And then we can use that cluster that is going to come in here. When you see, when I apply that clustering, and since there are not that many nodes, it's actually quite fast. And then it's going to show you what is the cluster for that. So in this case, it's like cluster 30. So we can use like a color scale for that. So let's create a color scale. And this is going to be a scale ordinal. You can say that, for instance, it's going to be scheme category 10, but as you just saw, we might have 30 clusters. So we will get some color repetition, but just for the sake of the example, let's leave it like that, and because I'm lazy. And then let's say here is my field, and then we are going to get the nodes color of the dot cluster. That is where it is coming from. So as you can see, now we can see the clusters with some repetitions. And if you want to keep on going, there's a lot of things that we can do, change a lot on the formatting. One of the things I really like of this is that if you take a look, and this messed up all of my styles, messed up all of my texts in here. But if you select, for instance, the tweet by date of creation, so here are my more recent tweets, then you can see that I have been tweeting the high school data science. I think the MITS program might be around there somehow. But I'm using that not as a hashtag. Then you can see hashtags from the pandemic, from the COVID pandemic. And the cool thing about this is that it's recomputing the clusters every time I rerun this. So, and then you can see, for instance, that before I used to use InfoVis before database that much, and the Human Computer Interaction Lab, and you can see the evolution. So this is one of the ways you can create network visualizations. Remember that you can also do matrix visualizations. If you want to do a network matrix, it's just thinking of scale ordinals and distribute your nodes, and then use a marked rectangle in the middle with whatever value you have. So if you want to see a more advanced version, like here is the final one, just search for this notebook, and then you will see that I added also my group in a box force in there, and I added this slider where I could select like how many, like keeping only the hashtags that had more than a certain number of links. So I hope you can use that. This is the one for force boundary, and I hope it is clear and that you can use it for creating your own network visualizations.